Oh, hi, welcome. This is lab number 8, which is through remote instruction. What this means is you will complete the data sheet, which I will share with you on Canvas by using the data already filled in to do the calculation. The purpose of this lecture is to give you an overview of what titration of neutralization reaction. There are two parts, part A or 4.3, part B or section 4.4. Allow me to share my screen and I will walk you through the concept of titration and how you will complete the data sheet showing the calculation. Right now, I'm going to share my screen, show you the PowerPoint slides. On my left, this is illustration of what the titration is all about. Titration is conducted by using a device called Purette. This is a common classware used in chemistry, typical chemistry lab, and this is called the stopcock. And this is the parallel you can see from here. I hope you have seen it before in Intro to Chemistry. The analyte is always what goes in the under the purette, and the titrant goes in the purette. Purettes comes in different dimensions. We have 50 ml, 25 ml, 10 ml. In this case, 50 ml purette was used. An indicator is used in titration to signify the endpoint. Endpoint is a rough estimate of equivalent point. Equivalent point is a point where there is equal number of moles of the titrant and the analyte. You need to read more about titration indicators in any general Chem 1 lab. So here, this is a cartoon, this is an illustration, typical setup of titration. There is a purette here, this is purette stand, purette holder on this side. Typically, acid-base indicators, phenolphthalein in this case is used to indicate the endpoint, and it changes color at equivalent or near equivalent point. The purpose of this lab is to introduce you into the concept of titration, and hopefully down the line you'll be able to perform titration or have hands-on experience on titration. There are two parts in this case. Part A is standardization of the NaOH, even though it's indicated as 0.1, sometimes it can be less than that, it can be more than that. So we use what we call primary standard. In this case, potassium hydrogen thalate, or simply KHP, is used to standardize NaOH or sodium hydroxide. Once we figured out the concentration, the actual molarity of sodium hydroxide, we will now use in section 4.4 to determine the concentration of acetic acid in vinegar, determine the mass percent. Read more on the background, read more on the concept of titration in the background, especially knowing what standardization is. All right, standardization is a process of determining the exact concentration. This is what you will be doing, or you have to do in section 4.3. The calculation in section 4.3 is tailored towards determining the exact molarity or concentration of NaOH, and then thereafter we will use in section 4.4 in determining the mass percent or the amount of acetic acid in vinegar. using the titration technique, and simply it's an analytical technique used in determining the concentration of a known solution. In this case, we call it the analyte. The terms you see in italic highlighted, these are the terms you should be able to commit to your memory. It will come back down the line. At the end of titration, there is color change, and this color change indicates the endpoint. Endpoint is a rough estimate of equivalent point. An equivalent point is simply the point in titration where is the theoretical equivalent number of moles of the analyte and the titrant. We call that equivalent point. In this case, our analyte is sodium hydroxide, which has what? Which has OH. And the analyte, which in this case, acetic acid in vinegar, got hydrogen ion, it is an acid. So basically, this is an acid-base neutralization. It is one of the reactions we have seen to this point this semester. I've explained before what an indicator is. There are several indicators used in chemistry, and in this experiment, phenolphthalein, right? Phenolphthalein is an indicator. It is colorless in acidic, and it turns pink in basic media. Now, NaOH, which goes in the puree, and potassium hydrogen this is used in standardizing NaOH. And if you look at the stoichiometry, 1 mole of KHP react with 1 mole of NaOH to form ammonium talent and what H2 in 1-to-1 mole ratio. This is the balanced equation you need for section 1, section 4.3. This is the balanced equation. Take note of the chemical formula for what? For KHP. Quite often students use this. When we say KHP, you may think that this is what you will use in determining the molar mass. No, you got to use the entire what? The entire chemical formula in finding the molar mass. And then in section 4.4, this is the balanced chemical equation between, all right, reaction between sodium hydroxide and acetic acid. All right, this is acetic acid in vinegar. Simply, this is CH3, COOH. It's the same thing as what you see in the PowerPoint slide on my whiteboard. That is the chemical formula. You will need this in finding the molar mass. Hope you know how to find the molar mass. You're gonna need to find the molar mass of this compound down the line. I'm gonna show you in section what? Section 4.4 when we get to completing the data sheet. I don't want to go in details into titration curve. You will cover this in general chem too. Typically when during titration, there is what we call conditioning the puree. Conditioning the puree is simply cleaning. You may not see from where you are. I'm holding the puree right now. And conditioning puree is just maybe half filling or using 5 ml of your titrant and swirling back and forth like this until, it's kind of like rinsing, and then you drain, all right? When you open perpendicular, it's open. When it's parallel to the parallel, this is top cup. When it's open is when you have condition is cleaning. I want you to, during your own free time, check on this link so that you are well fast with the titration. These are the classware equipments you will need or you are to use in this lab. In this case, analytical balance for weighing out the KHP. This is for taking the mass of what? KHP. The ring stand, all right? The puree clamp, you have used this before. The stirring rod, the stirring clamps for what? For stirring the solution. Here is the LMR flask. Just gonna put the analyte. And the bar, you have used this before, scupular spoon for scooping the KHP, and then the volumetric pipette. In this case, volumetric pipette, right, has calibration mark. We used this before, right? We used this in the previous experiment, molarity and dilution. There is a calibration mark along the neck. This is calibrated to deliver. This means to deliver. That means gonna deliver exactly 10.00 ml, 10.00 ml. So pay in mind that the volumetric pipette we use in this case is 10 ml. Now, the indicator is just to indicate the color change, and the acetic acid here, this is acetic acid in vinegar, acetic acid in vinegar. Safety rule always, no drinking, no eating. Of course, you are well fast with this. I don't want to spend time going through the safety precaution. Now, what you see here is for section 4.3, all right? Section 4.3, you will have this. I'm gonna post this on Canvas. I will upload on Canvas. Watch the related link. Here are the data. These are the data collected by instructors who ran Naveen, which you will use to complete the data sheet. Here is the mass of LML flask and what? KHP. Here is the mass of the empty flask. The difference between the two, of course, you can get what? Mass of the KHP. And remember the chemical formula for what? For KHP. This is not a complete chemical formula. This is the initial urate reading. This is the final. This data here you see is for section 4.3. For section 4.4, these are the data you will need to complete the data sheet. I will pull, let me share the data sheet and walk you through how you're going to complete. I don't think that is what I wanted. Let's see. You have the data. We just have here the information you see here. You will use in what? In completing the data sheet. This is the data sheet on page 155. Fill in here based on what we have on this slide. I'm gonna upload this slide. You have the mass of the flask. You have the mass of the LML flask. That's what you need to do what? To complete the data sheet. I see there was trial 3. You're gonna do the same thing. Of course, you can find the mass. The difference between the two here will give you the mass. The difference between the two will give you the mass of KHP. Now, for line 2, let's see what you do for line 2 is this, number 2, and I want you to take notes on each line. Line 2 is the number of moles of KHP, which means gonna be mass of KHP, and please use the correct molar mass to find the number of moles. This is from the molar mass. 1 mole of KHP weighs, molar mass of KHP. Use the periodic table to find this. Use the periodic. That's what you need to do for what? For line 2. I'm not gonna use that equation. You can find the molar mass. This is how you will set up your calculation. What is the mass of KHP? It's gonna be your what? The mass, you're gonna plug it in this equation. This is from the molar mass of KHP, molar mass of KHP. Initial volume, final volume for number 3, all right, number 3, it is V final, that is the final, minus V initial, V initial. So you're gonna have that for line 3, and of course you're gonna have in ml, the units will be in ml, in ml, moles of, all right, volume of NaOH, moles of KHP equals to the moles of NaOH. In this case, if you want to show your setup for number 4, number of moles, if you know the number of moles of KHP, that is from line number 2, sorry, from line number 2, you should have the number of moles of KHP times the mole ratio. 1 mole of KHP equals to 1 mole of what? 1 mole of NaOH, NaOH. This is mole what? Mole ratio. This is the mole ratio, from the mole ratio. And then you're gonna have XX moles of NaOH. This is just a setup on how you will determine the number of moles of NaOH in what? In line 4, line 4. Now, line number what? Line number 5, all right? Line number 5, this is molarity or concentration. Molarity, all right, is given by the number of moles of what? Number of moles of NaOH of volume in liters of NaOH. Remember, this is from line, this is from line what? Line 3. This is from line 3. And you change that to what? Change that to liters. Remember, 1 liter equals to 1,000 ml is equals to 1,000 ml. So you need to change the volume from line 3 to liters using the conversion. I know you are familiar with factor label method or dimensional analysis. Set up your equation, cancel the units, and proceed with the calculation. I want to see that you have attached extra sheet of paper if the space provided or given in the lab manual is not enough. You will do for the 3 trials, and then of course you will find the average. All right, number 6 is trial 1 plus trial 2 plus trial what? Trial 3 over 3 to find the average. That's what you will do to find the average. I'm gonna do that so that I get the average for the 3 trials. So that will take care of section 4.3. Please remember to write the balanced equation. I'm gonna write the balanced equation here. Otherwise, you lose points for that. You lose points for that. Let's see. 4.4, all right. Section 4.4. I'm just gonna say 4.4. Titration of vinegar sample using phenolphthalein. So in this case, it's assumed that the NaOH standardized from section once you standardize the NaOH using the KHP, this is the purette, and then this is our what? Our vinegar. So we have here 10.0 ml of what? Vinegar. So this is the vinegar. From the instruction, read the background. The molarity or the average molarity from section 4.3, you're just gonna bring it here. Now, volume of vinegar here is 10 ml. That's why I do have it here. It is 10 ml. You will use what? We use the this is the volumetric pipette. All right, you're gonna have volumetric pipette in there. So 10 ml. This is where the 10 ml is coming from. From what? And then we add 2 drops of phenolphthalein. This is the indicator which will change color. And you have to do this for 2 trials, trial 1 and trial 2. You will see the data for trial 1, trial 2. Now for number 8, this is, let's say we have performed the titration. The data is given in the PowerPoint slide. Number 8, what you do is do what? Find the mass of solution. This is mass of vinegar solution. The reason why you are given density here, is so that you use the density equation. Density equals to mass over volume, which means mass is given by our density times volume, density times volume. So that's what I do have here. And the equation you will use to find the mass of your solution, mass of the solution. And remember, the volume here is 10.00 ml. If I have ml, that is the density, or rather grams per ml. Let me just make here. This is what I meant to say, grams per ml times ml for unit cancellation. You will remain with grams of your solution, This is density times the volume. Volume based on what we pipette. Use pipette, 10 ml volumetric pipette to get what? To get the volume of the solution. And then titration here now, this titration till initial and final. That means when the meniscus is up here, let's see here, this is V initial, and then here is V final, V initial and V final. The data you plug in here is given in the PowerPoint slides. The difference between the two is gonna give you the final number 9 here, number 9. V of NaOH is given by V what? Final minus V initial. This is the equation I want to see in your calculation. V final minus V what? V initial. Give you volume of, and remember, this is in ml. The volume is in ml. Now, most of NaOH use at equivalent point. So if you know the volume for number 10 here, number 10, molarity equals to number of moles over volume in liters, This means number of moles of NaOH equals to molarity of NaOH times volume in liters of what? Of NaOH. That is what you need to remember, that how are you going to get that as number of moles in NaOH. We calculated P4, this is line 7 right here. This is line change to liters, line 9. This is line what? Line 9 in liters. Remember, 1 liter equals to 1,000 ml. That's what you'll use to change that, line 9 in liters. That will give you the number of moles using this equation. That equation for line 10. Moles of acetic acid. I want you to take note of number 11 here. Number 11. Acetic acid. This is acetic acid. It is acetic acid in vinegar. Acetic acid in vinegar. So we didn't measure out acetic acid, but acetic acid is the component of what? It is the component of vinegar. In the PowerPoint slide, there is this equation, CH3, COOH aqueous reacting with NaOH aqueous to form sodium acetate, CH, no, I meant to say CH3, COONA, this is sodium acetate, soluble in water, aqueous plus H2O. The mole ratio here is 1 to 1 to 1 to 1. So mole ratio is 1 to 1, which means, all right, which means the number of moles of acetic acid is equals to the moles of NaOH. Moles of acetic acid is the same as NaOH. So if you want to show your calculation for number 11, we're still on 11, will be the number of what? Number of moles of NaOH times moles of CH3, COOH, this is acetic acid, CH3, and then moles of NaOH. And if you look at it, it is 1 to 1. So you're gonna have to cancel the units here. This will give you moles of CH3COOH. This is acetic acid. This is how line 11 will be calculated. The number of moles of acetic acid is the same as the number of moles of NaOH. Unit cancellation, you will be left with moles of acetic acid. Recall how to find the mass given the number of moles. Number 12 here, number 12. Number 12 is finding the mass from the number of moles. You know, you can find the number of moles using the mass in grams over molar mass over acetic acid. This means mass in grams is given by the number of moles times what? Molar mass of CH3 COOH. This is given from line 11. We know the moles of acetic acid. Use the periodic table here. Use periodic table. Use periodic table, PT for periodic table. All right, PT for periodic table. And that should give you the mass of acetic acid, mass of acetic acid. Now, line what? Almost done. Line 13, 13, we know the mass percent concept, mass of the component of the total mass, all right? So here, mass percent of CH3COOH is given by the mass of what? Mass of CH3 over mass of vinegar solution, which means times 100%. So this is going to be mass of vinegar. This is line what? It's gonna be line 12. We know line 12 over line what? Line 8 times 100%, and that will give you your answer. That will give you the mass percent of vinegar, mass percent of acetic acid in vinegar, mass percent of acetic acid in vinegar sample. Now, 14 here, number 14, molarity of acetic acid. Of course, we know molarity is given by what? Molarity is equals to number of moles of CH. We're not talking about acetic acid. We know the volume of what? This is volume in liters. Recall the volume we use. This is the volume used in titration right here. We use 10 ml of vinegar solution. Forget about how you diluted that, but that is the volume you need to remember that is going to be used here. 10.00 ml. How many liters? Number of moles of acetic acid. This is line right here, line 11 moles of acetic acid over volume of vinegar solution in liters should give you the molarity of acetic acid. You're gonna do the trials, trial 1 or trial 2. Mass percent, of course, everybody knows mass percent. Number been using red, so it's gonna be number 15. Mass percent of mass percent of acetic acid in vinegar, molarity of acetic acid in vinegar. I've done that. Yes, I've done that. So I meant to say number 16, average mass percent. All right, average mass percent is mass percent is given by trial what? Trial 1 plus trial what? Trial 2 over 2. It's just everybody knows that. And lastly, number 16 here is the average molarity. Average molarity is given by what? Is given by trial 1, molarity for trial 1 plus trial 2 over 2, and that will give you the molarity here and you will submit your data sheet through Canvas. Other than that, good luck. I'm gonna stop sharing my screen. Good luck. Thank you.